Okay, so for 7.2, this is solving linear systems by graphing. So yesterday we looked at the equations, right? And we set up linear systems. And now this is graphing. And when you're graphing a system of equations, all you're doing is you're given two equations, and then you have to graph them on the same grid and then figure out where they intersect on the plane. Now, so here we've got 2x plus 3y equals 3. Now, I can rearrange this equation. So let's call it equation 1. Let's call that equation 2. I can rearrange this equation so that I have it in y equals mx plus b form. So in order to do that, I solve this by subtracting 2x on both sides. Then I've got 3y equals negative 2x plus 3. And then I divide everything by 3. Now this gives me a slope of negative 2 over 3 and a y-intercept of 1. So first I want to plot my y-intercept of 1 right here. And then I'm going to go down to, yeah. Oh, that's not 1. I have to watch my scale. Okay, so 1 is going to be right here, because that's a half. Okay, all right, so then I go down 1, down 2, and then over 3. So that's where my next point is, right? So what's this point right here? 3 and negative 1. And if I want, I could go up in the opposite direction. So up 2 and then over 3 again. So what is this point value way over here? So that's negative 3 and that's 3. Okay. All right, so now let's... Okay. Okay, so now I've got a couple of points labeled. Now I can graph the other line. So I've got x minus y equals 4. And I can solve that for y equals mx plus b. So subtract, I can subtract the y on both sides and then subtract the 4. Wait, I'm going to add the 4 on both sides. So I've got y equals x minus 4. Okay, so I can plot my minus 4 right here. That's my y-intercept, so that is 0, negative 4. And then I go up 1 over 1, so I got a rise of 1 over 1. And I just plot those points there. And so what's the solution to my system here? I can plot another point. I can label another point. So this can be 4, 0. So my solution is the point where the two lines intersect. Is 3, comma, negative 1, where the two lines okay. Now, number 2. So number 2 talks about Jaden, who left her cabin on how do we say that? Waskew Lake in Saskatchewan and paddled her kayak towards her friend Tyrell in an average speed of 4 kilometers an hour. Okay? So Tyrell started at his cabin at the same time and paddled at an average speed of 2.4 kilometers an hour towards Jaden's cabin. So the cabins are 6 kilometers apart, and the linear system that models the situation is this right here. So which equation do you think is related to Tyrell's cabin and his speed? So the first one, because Tyrell's going 4 kilometers an hour. And how about the one involving going towards Jaden's cabin? So this is the speed that's associated with going towards Jaden's cabin, right? All right, so now we have to graph these two lines on this grid. And what are we going to assume is the independent variable here? So I've got time and I've got distance. So what is the independent variable? So the independent variable is time, right? So that's going to go here. And then distance is going to go here. So instead of x, this is really t that I'm graphing. And instead of y, this is really d that we're graphing here. All right. So let's call this equation 1, the d equals 6 minus 4t. And can I think of this one? It says d equals 6 minus 4t, but it doesn't really look like it's in y equals mx plus b form, does it? So what can I do to make it look like it more? Kind of rearrange this here? Usually, yeah. So what's my rate of change? D equals negative 4t plus 6, right? So then my y-intercept for this first equation is plus 6, which is off of my graph. So it would be right here. And what's my rate of change? So down 4 and right 1. Okay? So if I am starting at 6, excuse me, and I go down 4, 2, 3, 4, and then over 1. Now again, let's watch our scale, right? Thanks for reminding me on that first question. And then if I go down 4 again, well, I can't go 4 because, well, 4 is going to land me here. And then where is this 1 going to land me? So this is negative 1. This is going to be at negative 2, right, on my y. And then over 2. So that's going to be negative, 2 and then negative 2. All right. So if I can get a straight edge and draw that in. Okay. Now, where would my graph stop for real? Would it go down in here? No, why not? Because then I'm going past the cabin, right? So I'm going to ignore this part, and I'm really only going to care about what's above the x-axis, okay? This is past the cabin. All right. So let's graph our other equation now. What's the other equation? T times 2.4d. Okay, so that means the slope is 2.4 up and vertical intercept is 0. So that means that I start right here and then I go up 2.4 for every 1. Now, okay, what is 2.4? Can I convert that to a fraction and get a better idea of what the slope actually is? It's like 12 over 5. So if I go up 12 every 5 over, I can do it that way, but that's not going to fit nicely on my graph. So let's see if we can estimate what 2.4 is. What are these separated into? They're in 0.2s, so I can just go up 2.4 here and then over 1. So that kind of gives me a good estimate of where I am. Okay. All right. So where does this graph intersect? Well, where would you assume that number is approximately?
2.2.
So you're thinking maybe it's at 2.2. It's not quite at the 2.4. And how about on the x-axis here? Where do you think this is? Has it gotten to 1? Not really. It's pretty close, right? So for this, let's estimate that that point is around 0.9 and 2.3 or 2.2. Okay, so here we're just going to approximate the solution because it's not exact numbers and we've got decimals. The only way you could actually get an accurate reading on here is if you're using a calculator with graphing software in it or a computer to generate the diagram for you. Okay. So when do they meet? How far away are they from Tyrell's cabin? They're about 2.2 kilometers away from Tyrell's cabin. Yeah. Okay. And when do they meet? Not quite an hour after they leave, but a few minutes before an hour. So we could say it like, so 0.9 times 60 is what's going to give you how many minutes? So we could say 54 minutes. Okay. All right. Now, yesterday we did some practice with questions where we were setting up systems. Okay, and here I've just given you a grid so you can use to kind of organize your thoughts. But we're looking at this system here. So it says, write a linear system to model the situation. Wayne received and sent 60 text messages on his cell phone in 1 weekend. You guys got that beat, right? Oh yeah, okay. He sent 10 more messages than he received. Okay, so we need to figure out how many he actually sent, how many he actually received. So what do we know so far? What are the givens? Okay, so we know that there are 60 messages sent and received. So, okay, what would be an associated equation for this? What should we call S? I mean sent. We'll call sent S, and what should we call received? R? Okay, so what equation can we associate with this? R plus, sorry, S plus R equals 60. Okay, and now the other piece of information is that he sent 10 more than he received. So how are we going to set that up in the other equation? So S equals ten plus R. Right? So 10 more is the 10 plus than he received. There's other ways of writing this equation, right? You could have written S equals R plus 10. You could have written S minus R equals 10, but they're all just rearrangements of each other. So the system that you would have is S plus R equals 60, and then you can write S equals 10 plus R. So this is your system of equations that would associate. So now what we're going to do is we're going to take these two equations and we're going to graph them. And let's use the intercepts to graph these equations, just because we've already used slope-intercept form in the previous question. So let's practice this with intercepts. Okay. So let's call this x-axis, let's call that the sent messages. And then let's call the y-axis R, which is the received messages. Okay. And so now we can rearrange them so that we've got our R-intercept. So how are we going to figure out our R-intercept for this first equation? S plus R equals 60. What do? We set S equal to 0. So then I have R equals 60. Okay. And then what is the S-intercept for the same equation? What do? We set R equal to 0, and then we get S equals 60. Okay, so that means my intercepts for that equation are both going to be at 60. Well, notice we don't have a scale written out here for us on this graph, so we need to figure out what's a good scale going to be. What do you guys think? You go up by 20? So 20, 40, 60, or I could go 10, 20, 30, 40, 50. I won't quite get to 60 if I do that, right? So let's go up by 20. Okay, so 10, 20, 30, 40, 50, 60, 70. Okay, so then I've got an intercept here, and I'll do the same thing for this side here. All right, and then I've got an intercept there. So get my ruler. All right, now what can I say about these values that go beyond the x and y axis here? What can I say about that part of the line? Does it exist? Does that exist here? No. So I can erase that so that I am not worried about that, because I'm not going to send negative text messages. All right. Now, let's have a look at the other equation. What's the other equation I have? S equals R plus 10? Okay, so what's my S-intercept? My S-intercept, I set R equal to 0, so S equals 10. And what about my R-intercept? I set S equal to 0, so I end up with, so 0 equals R plus 10, or 10 plus R. So what does R equal? Negative 10. Okay, so that means my R-intercept is going to be down here at negative 10. And my s-intercept, where's my s-intercept, is going to be at 10. Okay? So I can just follow this a little further, just follow the pattern, kind of get a few more points on my graph so I know where I'm going, I know where I'm headed, and then I can get a straight edge and draw in my line there. Okay, now again, what am I going to do with this area down here in the negative? I'm going to ignore it, right? Because I can't send negative text messages or receive negative text messages. Well, all right, now where is the solution to this system? So where, that's going to tell us how many text messages Wayne sent and how many he received. So that's going to be right at this intersection point, right? So what do we think that number is approximately? 35. And if I go here, what do I think this number is approximately? 25. So then my solution to this system is 35 and 25. So at the bottom, I can write a statement saying Wayne sent, how many did he send? 35 messages, and he received how many did he receive? He received 25. Okay, and this is the x-coordinate of my solution, and that's the y-coordinate of my solution. So every time, all you're doing is graphing the two lines and finding where they intersect. Okay, sounds good? And the homework's here. Make sure you guys have a look at the homework questions on page 409 and also the assess your understanding on page 415, okay?